Welcome everyone to today's webinar, Introduction to Progress Corticon. One good decision leads to many more. This is Marlis Furs, your host for today's session. We are pleased to have Dr. Mark Allen, our Chief Technology Officer for Decision Management, as our speaker today. Dr. Allen is one of the leading authorities on business rules management. He began working with business rules software in the mid-1990s. Building systems that helped healthcare workers make better patient care decisions. In 2000, after years of working around the shortcomings of existing technologies, he founded Corticon to deliver a business rules platform that could scale to handle the most sophisticated decision-making problems. Under his leadership as CEO, Corticon became a leading business rules platform in healthcare and diverse industries such as financial services, government, manufacturing, and insurance. Since the acquisition by Progress Software in late 2011, Dr. Allen has been a CTO, helping to evangelize the benefits of Corticon across the world. Welcome, Dr. Allen.
Thank you, Marlise, and thank you all for joining. Very excited to tell you a little bit about Corticon, something that I'm very passionate about, been working on for quite some time. I'm so passionate about the benefits that it can bring you, and I'll talk about a lot of the benefits that a lot of our customers throughout the world have gained from using Corticon. So first I'm going to start with an introduction, make sure that everyone understands what business rules management is and what problem Corticon was founded to solve. We'll go into some detail about the Corticon solution. And then we'll talk about our customer success, and I'll give a variety of different examples, hopefully some that are relevant to you. I'll then talk about how Corticon is different. And I'll even demonstrate the product to you because a picture is worth 1,000 words. And then we'll summarize and go into some Q&A. So Corticon is software that helps your business to make the right decision at the right time with business agility, with the agility to change the way that you make that decision. What do I mean by decisions? For example, should we pay this claim? If so, how much should we pay? Should we go after somebody else to help pay a portion of this claim? What offer should we make to this customer? Based upon a combination of this customer's history with us and what this customer is doing right now at this instant in time. What resource should we allocate to this task to make sure that we cover it appropriately with the right degree of skills as quickly as we possibly can? So, what's the connection between decisions and business rules? Decisions are governed by business rules. For example, the decision of should we pay this claim might be governed by hundreds or thousands of rules, such as this one. Reject a claim with an invalid billing code. That's a very simple rule. Well, you might have 100 rules that describe what invalid billing codes actually mean. So a business rules management system, also commonly referred to as a rules engine, is software that helps to externalize this type of logic from the rest of the application logic and manage it rather than as programming code as business rules that are understandable by business people. Now you still have the system of record. In this case, you still have a claims management system that stores and persists the data of the claims and provides user interfaces or messaging interfaces to receive the claims. At the point in logic flow that you need to make a decision, if you're using a BRMS, you send a message out to the BRMS with the relevant data of that claim. The BRMS then fires its rules against that claim and sends back a result. Now, in addition to sending back a result, here's how much you should pay, it provides an audit trail of exactly what rules fired in what order so you can understand why it gave the result that it presented. So why did we create Corticon? So as Marlise mentioned, I was building rule-based systems in healthcare. My co-founders were building rule-based systems in financial services and in HR, and we all had a common set of problems. It was pretty easy to build systems with a few rules. But as you added more and more rules to those systems, the amount of time it took to add a new rule grew exponentially with the number of rules existing in the system. Why is this? Because rules interact with one another in complex and sophisticated ways. If you only have 2 rules, you only have to look at 2 interactions. Once you have 1,000 rules in your system, you'd have to look at 1,000 interactions when you add in a new rule. So this problem gets very complex. And the problem is, in addition to just the complexity of the rules change quite often, and often by forces outside of our control. So a government could introduce a new regulation that we need to comply with, otherwise severe penalties occur. Or new competition comes into the market and we need to change our prices or add a new product to be able to compete with them. So once we have sophisticated systems that are automating lots of rules, these simple changes that business people can describe to one another in a matter of minutes can take man-months to change in the existing systems. So this is the problem that we were confronted with, and we realized that there had to be a better way, and we built that better way. So that is Corticon and the Corticon Business Rules Management System. So what exactly is it? It allows you, first of all, to separate out the decision logic from the rest of the code and empower business users to actually manage that logic in a form that they understand. Okay, we've built a tool that allows the modeling of this type of logic in a spreadsheet-like interface. Very simple for business people to learn and understand. In addition, application developers are often users of this product, and they can pick it up in literally a matter of hours and become rapidly productive. So this tool allows for the expression of this type of logic, decision-making logic, in a form that has integrity. By integrity, it means that you understand the interactions between your rules. When you add in a new rule, it doesn't break your system. Very key concept, very similar to the concept of relational integrity in a database. Without integrity, you can add garbage data into a database. Without integrity in your rule base, you can add garbage rules into your rule base. So once the rules are modeled, they are immediately converted into an executable form and can be tested by the business people and then added into your existing systems using open standard interfaces. So the Corticon rule models can be automatically converted into an executable form that runs natively in a Java or a .NET environment and can run as a standards-based web service. So very easy to call or add into an existing application without requiring any proprietary skills. Now what's really important here is not only that we generate an executable, but that we generate a very high performance executable. In fact, what we generate is far higher performance than about the world's best programmers can generate. Highly optimized code to run these types of rules to assure scalability across a number of different factors. And last, it's really important to offer the ability to make safe and easy and quick changes to those rules. When a change occurs from a variety of sources, you simply pop open the rule model, and if you've got the proper authorization to make the change, you make the change, the software tells you the impact of the change, what other rules are impacted, and allows you to safely make changes in minutes rather than months. Now, Corticon can be integrated with a number of existing legacy systems or new systems, can work either on-premise or on the cloud, and you can either pass it the data that it needs, or it can actually retrieve data from existing data sources through a number of high-performance mechanisms. So let's talk about Corticon Success. So the product first launched into the market in late 2001, was our version 1. Since then, it's been deployed at well over 500 customers in a whole variety of different industries. So a lot of work in insurance, financial services, government, both on the federal side as well as state and local. Health and human services, back to my background, is one of our most important verticals, both on the payer side as well as provider side. and a number of e-commerce companies use the software. So I'm going to dive into a few of these examples. So first of all, looking at use cases across industries, kind of grouping those use cases, we see a lot of common patterns. So first of all, in the process of selling and marketing a product, Corticon can add a lot of value, okay, in helping customers to apply for products in a more automated and self-service fashion, providing the automated generation of quotes that consider all pricing policies, discounts, regulations, being able to recommend products based upon what other customers have purchased or likely to purchase, and policing that process. In terms of customer servicing, also we make this a lot easier and a lot more automated and self-service, from taking in the data, again, what's relevant based upon what your problem is, validating that information, adjudicating the problem, in some cases being able to completely address the problem in a self-service way without touching another human, and being able to recover and look at fraud opportunities. Manufacturing and supply chain. One of the biggest oil and gas companies uses Corticon for voyage planning. Anytime that they route a tanker or barge anywhere in the world, very complex decision-making that involves a 200,000 vessel fleet with inspection records on thousands of different parts that may or may not be relevant for the given cargo. And they have to look at weather patterns across the world, across the various voyage plans. We also have companies that have built ERP systems or added decision-making components to existing ERP systems. Lots of interesting applications there. Now, last is what we call enterprise rules management. And this is really, many of our customers start using Corticon for one decision, okay, one decision that they need to improve in their business. But as they gain success in the initial application, they begin to ask the question, why don't we build all of our applications this way? This is an easier way to both build the applications and then to address the agility that naturally occurs. So if we think that this area of the application might be subject to change, let's build it in Corticon. Now that's the IT perspective. From a business perspective, the business, when they automate decision-making logic today in the form of code, they actually lose transparency to that logic. Many of our customers don't even know how they make decisions today. It's somewhere buried in that code. Well, using Corticon BRMS, that logic stays transparent. It stays managed by the business with the ability to change, optimize, and improve that decision-making logic. So let's go into a specific example here. This is online insurance sales. This came from one of our customers that was selling health insurance to individuals. They were selling through a network of brokers in certain geographies, and they wanted to expand into other geographies. They realized it would take them a long time to build up their network of brokers, train their network of brokers. They said, you know what, we're going to build a web-based self-service online sales platform. And they looked at various technologies, and they chose to build this on Corticon and just some custom coding in Java around Corticon. So looking at this process, a customer completes an application. They underwrite the application, determine what price to provide, maybe recommend certain products. They close the sale on the product the customer wants, and then they send out the premium document. Now, where do rules apply? All throughout this process. So in the process of completing an application, based upon the answers to certain questions, you need to answer other questions. Very simple example. We're going to ask if somebody is pregnant only if they're a female and of a certain age. Otherwise, we don't need to ask that question. Likewise, we will need to ask female pregnancy health questions if somebody is pregnant. Otherwise, we don't. So how's that handled today? Well, an initial form is filled out, and then based upon certain answers, maybe somebody calls you to interview, or maybe they mail you another form. It takes a long time. You can automate that delivery of that conditional type of data collection very easily with the rules engine. So next, underwriting, quoting, and recommending. So this is where a huge amount of statistical analysis, a lot of science goes into this. Actuaries that are statisticians that understand how to look at existing claim data and determine how to figure out risk and how to determine price. And so literally thousands of rules can go into these types of applications. Now last, the generation of the policy document itself. So we could create a policy document that matches every single customer. And in order to do that, we need to have writers for every product or every option that a customer might possibly pick. We need to define rules that apply in certain states but don't apply in other states. Or we can use a rules engine to determine, based specifically upon what this customer purchased and where this customer is located, let's create the most efficient, smallest possible policy document for that customer and use a PDF tool to generate what the rules engine says. So we've done all of this using Corticon. So after an online form is filled out, it looks like a simple web-based form, only it's very dynamic. This is what pops up. So what you see here is monthly premiums already calculated out. 3 different products are displayed for each customer. A policy document is automatically generated as a PDF that a customer can review. And this woman is a little video, and she talks about why one of these products is best for you. So looking at the benefits here, this particular customer was able to, first of all, grow a new revenue channel that they didn't even have and bring it to market much more quickly than other alternatives. They were able to streamline a process where the industry average, from the time that the company receives an application from a customer to the time that they close on that customer, the industry average is 14 days. They were able to decrease that down to as little as 10 minutes for the healthiest applicants, where they ask the fewest questions because those are the most profitable applicants that they want. And last, they're able to respond very rapidly to changes in market direction. When they want to add a new product into their mix, they can add that in a matter of a few days or weeks at most, as opposed to any other process of either application development or manual processing would take months to add a new product. So let's talk about something from the customer servicing use case. In this case, we're going to talk about claims. We're using some of these use cases that pretty much everybody has experienced. Applying for insurance, submitting a claim. So claims, unlike applying, is a long-running process, often involving many individuals in the process conditionally. So in this particular case, this was based upon some work that we had done with the State of Texas Department of Insurance for workers' compensation claims adjudication. In this particular case, they were very proud that they were using best practices in business process management. They were using a BPM workflow tool to route work from one person to another, so the claim document was digitized. It was no longer in paper. They could tell how long it took for each person to do their task. Now, every one of these red steps is a manual task. So while they've automated the paper, most of the work was still being manual. So we looked at this, and we looked at each of these tasks and asked the question, what's this person doing? Are they making a decision? If so, we can capture that logic and automate it using Corticon. What we did is one at a time, one step at a time, we captured the logic of what decisions these people were making. So for example, one group determined whether the claim was likely to be fraudulent. And if it was, then the claim would be sent to a special investigator who would go and do a site visit. Now, after applying Corticon over a period of time, we were able to automate the majority of manual steps in this process. So we could automate the step to review for fraud, but we didn't automate the step to go and do the site visit. That still required manual intervention, but that was conditional. So we were able to achieve a much higher degree of automation of the actual claims processing tasks. So when we look at the benefits here, so our customers, and we've actually done claims handling across just about every type of insurance and other type of business claims handling, from warranty claims to healthcare claims to life insurance claims. You don't want those. To workers' compensation claims. And what we find is that we're able to significantly accelerate the closure of a claim. We're able to reduce the cost of processing those claims by removing a lot of the manual intervention. And also, our customers tell us that the faster they're able to close these claims, the lower their payouts tend to be statistically. We're also able to improve quality. By doing this faster, their customers are happier. And last, and very critically, when you look at automation, it has to be agile. When they want to make a change, they pop open the step in the workflow tool, which links to the Corticon rule set or rule model. They make a change, they understand the impact of the change, they redeploy that change, and the next claim that hits the system will hit those new rules. So let's talk about a couple of other use cases. eBay, I really like this use case. This demonstrates the scalability of Corticon. eBay was, our largest competitor is IBM and their iLog product line, and happened to be iLog's largest reference account prior to beginning to use Corticon here. The eBay had a problem in trust in their marketplace. Sometimes a seller would misrepresent a product, or the buyer would at least think they misrepresented the product and would be unhappy with the purchase. And if they're unhappy, they're going to go to another marketplace. They're going to go to Amazon or somewhere else. So eBay said they need to address this problem and assume some of this risk. So they put in a buyer's guarantee. We'll make sure that you're happy with your purchase. Well, as soon as they did that, their profitability started plummeting. They started having to pay out these buyers. And they said, we need to shift this risk onto the sellers. So they created a set of policies that basically will hold money in escrow from a seller until certain conditions are met. And you can imagine these rules can be quite complex. They can be based upon the seller's rating, how new the seller is, what products they're selling, in what geographies where they might have had problems, which change all the time. And they need to be transparent ultimately to the sellers themselves what those rules are. So eBay put all of this into Corticon. They determined that that with the IBM product, they just couldn't manage the complexity. As they increased the number of rules in the rule base, they couldn't manage the complexity effectively. It took too long to add in new rules. Additionally, the performance was just too slow to scale to a real-time online transaction need. These transactions have to occur as somebody's placing a listing or as a purchase is occurring. They can't slow down the user. They determined that Corticon could handle this problem quite effectively, and they're now running upwards of 150 million transactions a day through Corticon. Very successful customer use case. Meridian is a health plan, and it was an existing existing Progress customer using the OpenEdge application development platform. They were confronted with a regulatory change from Obamacare, and needed to manage that change, and determined that even though the OpenEdge platform is a rapid development tool with a 4GL language that's highly productive, it would just take too long to program all of those business rules. They did a prototype with Corticon and looked at a variety of other solutions and determined that it fit their need very well, and have since been successfully building their application. So, to mention Obamacare, Corticon is a leading platform out there in addressing Obamacare. Thankfully, we were not part of the federal solution that you heard a lot of stories about, although if we were, I'm sure that there wouldn't have been those stories. That each state has an option themselves of developing their own solutions, and Corticon is the leading rules engine as parts of those various state solutions. Deployed very broadly across a number of states. CNAs is the Romanian government, and this is an electronic prescription system that is built by HP Enterprise Services using Corticon, specifically to address problems such as drug-drug interactions or fraud in prescription management. Unum is one of the nation's largest employee benefits providers and one of the largest life insurance providers, both in the United States as well as in the UK. They started using Corticon in just a couple of areas, but rapidly expanded to use Corticon in just about every area of their business. There are a couple of quotes that I thought would be really instructive here. So before Corticon, a customer could wait 8 weeks before a price quote, after a price quote was accepted, before their policy was issued. Now it takes as little as a week because they've automated so much of the decision processing. Additionally, from an IT perspective, they note that changes that would have taken weeks can now be made in days with all of the necessary IT governance and controls. That's very critical. By using Corticon, you're not putting your business at risk. You can still run your system changes through the same IT processes to make sure that systems are properly tested. It just is a lot faster and easier to make the changes to the logic. DBS is one of our customers, one of the largest banks in Asia. I just visited them a couple of weeks ago. Very exciting application there. They use Corticon for credit scoring models for all of their lending that they do as a business. So both secured and unsecured loans to both commercial institutions as well as retail loans in a variety of different geographies where the rules differ. So prior to using Corticon, they were audited by the Singapore Ministry of Finance, and they were found that they didn't have the proper controls. So this meant a lot of risk for their business, but even more, it meant that they had to hold a lot more money in reserve. So they began using Corticon for their credit scoring models, and they went back to the Singapore Ministry, and they showed them the controls that they now had in place. Now, the Singapore Ministry was thrilled with these controls and allowed them to lower their reserves, and of course, their business is in a much better place. So let's talk about some differentiation. So Corticon is recognized as a market leader by the analysts that cover this space. In addition to that, we are recognized as providing a breakthrough product. That's a big word for analysts to use. Forrester has called out our breakthrough capabilities for business analysts to be able to manage this type of logic without programming. You'll see this in the product. IDC has gone into a lot more depth, specifically in the areas of how we guarantee rules integrity and how we can assure optimal performance and scalability. So this ties into the areas of differentiation that I'm going to focus on and show you here. So first of all is model-driven development. So this is the ability to express this logic without programming code. Now, all of our competitors can express simple logic without programming code. But when you get into sophisticated logic, and by the way, most decision-making problems in the real world do, well, you have to manage that logic in code. So all of a sudden, you're taking out the benefits of why you would even use a rules engine if you have to manage some of that logic in code. And by the way, the code that's used by our competitors are proprietary languages to manage business rules. So with Corticon, you never get into code. Number two is guaranteed rules integrity. So Corticon basically has guardrails, and you're going to see this in the demo, that allow you to make safe changes. It points out when there might be logical errors in the rules. And this provides enormous benefits in productivity and also quality of the actual deployed system. And last is what we call our DD engine, our design time inferencing engine, which provides market best performance and scalability, specifically when it comes to data-intensive processing. So let's go into these in a little bit more detail. So Corticon provides a spreadsheet-like interface. And rather than talk about this slide, I'm actually going to demo the product to you. It's equally accessible to business analysts and IT programmers that have been doing application development in a variety of languages. So really this exact same tool can be used by both of these groups of people. And when you look across our customer base, we have users that come both from an IT background and a business background. So we'll show you that product. What's really key here is that it's proven across the most sophisticated decision-making problems. So in order to demonstrate Corticon, I'm going to set this up, and again, using this very simple application for insurance process. So the first thing is to understand where are the decisions in our business process. So in this case of processing a new application for insurance, when we sit down and break this up, we see that there are a variety of decisions. First, we validate the information. Then we determine the risk profile. Then we calculate the premium based upon the risk profile. And then we route it for approval before we send out that quote. So what we do when we use Corticon is we identify one of these decision points, and we ask the question, how do you make that decision? When we ask that question of people that perform or manage this step in the process, they give us business rules. So for example, in this particular case, let's suppose that we ask Susie, who manages our risk today manually. She says, oh, it's quite simple. There are only two rules. If an applicant's a skydiver, they're high risk. If an applicant's less than 35, then they're low risk. Now, these are absolutely trivial rules, only two rules. As I mentioned, most of our customers have hundreds or thousands of rules. I'm going to demonstrate this product using only these two rules to show you really the key principles of how you model business rules using Corticon. Once I show you this, I'm going to then show you a real-world case of how Corticon scales to handle complexity. So let's go ahead and take these simple rules and move over to Corticon Studio. Corticon Studio is similar to Excel. It runs on a Windows environment. It either runs as a standalone application or it runs in the context of an Eclipse application development environment, which is what a lot of the programmers prefer to use. In addition to that, we are in development of a web-based version of Corticon Studio that will allow our users to use this via the web. And I'm going to begin this demo. So first I'm going to orient you to the product itself. Down here in the lower pane are the rule statements exactly as expressed by our business. Up here is where we model the formal expression of those rules. We put the conditions in this section, we put the actions in this section, and we tie together the conditions and the actions in each column. Now, in order to do this, we need what we call the vocabulary. The vocabulary are simply the terms that are referenced by our rule statements. So things like applicants who have skydiver values and risk rating values. So let's go ahead and model this first rule. This first rule says, if an applicant is a skydiver, I'm going to drag and drop skydiver as my first condition, and I'm going to select if skydiver is true, then assign to risk rating the value of high. This implements my first rule statement. I see now that the rule statement is tied to the implementation of the rule. So let's go ahead and do the second rule. The second rule is talking about if an applicant's age is less than 35. So for the second rule, I say if age is less than 35, then assign a low risk rating. This implements my second rule statement. So I'm done with the logic of both of my rules. I'm going to go ahead and save these rules and test them. Testing, just like the expression of the logic, is meant to be business friendly. I'm going to open up a new test sheet. It's empty, but I'm going to add an example of an applicant right here. So if IT has hooked me up with my existing data sources, I can test against those data sources right away. In this case, I'm just going to build an applicant from scratch. So I'm going to call this applicant Tom. I'm going to make Tom age 30 and not a skydiver. So applicants who are less than 35, I would expect to get a high-risk rating. I would expect to get a low-risk rating, applicants less than 35. So I'm going to deploy my rules, and I run this test, and I see here the applicant received a low-risk rating, and I see the audit trail of exactly what rule fired. So I'm going to go ahead and copy this exact applicant and make a couple of changes here. So for the second one, I'll call it Dick, and the third one, I'll call Harry. So Dick, I'll make a skydiver. So applicants who skydive should receive a high-risk rating. And Harry will make 75 and see what happens. Now I'm going to run all three at the same time. And I look, no change in the first one, but look at Dick. Dick's a skydiver, but he received a low-risk rating. What happened with Dick? Well, if we look at the audit trail, we see, in fact, both rules fired. So first, he was identified as a skydiver and he was given a high risk. Then he was identified as less than 35 and given a low risk. So since risk rating can only hold one value, he ended up with low risk. Now, was this the intent of the business? Probably not. Okay, what this illustrates is not a problem with rule engines. It's not a problem with computer science per se. It's a problem with the specification. In this particular case, we have two rules that are conflicting with one another. We only have two lousy rules, and we already have logical errors in our rule base. So while Corticon has a cool testing tool, testing is the wrong way to identify logical errors. Why? Because when you have 1,000 rules in your rule base, how do you understand all the interrelationships? It's an intractable problem. You can't test that many scenarios in our lifetime. So in a moment, I'm going to show you a much better way to identify logical errors. But first, let's look at the third applicant. The third applicant has no risk rating. What happened here? Well, we have a rule if they're less than 35. We have a rule if they're a skydiver, but what if they don't match any of those conditions? Well, we don't have a rule. From a layperson's perspective, we would call this a loophole in our policy. Now, I've had the pleasure of working with many of the most respected policy-making organizations in our world, from the U.S. federal government, the FBI, a lot of states, some of the most prestigious healthcare institutions, some of the most the best financial institutions. And I can tell you, all of their policies have logical errors in them. Why? Because English is an imprecise language. So when you go to automate these policies, you have to get out the logical errors to get this logic right. Okay, so I'm going to show you a better way. But first I'm going to show you kind of how the testing helps you to identify what the right answers are. So this first one is right. But the second one, when somebody's a skydiver, independent of their age, the business says these should be high risk. Okay, likewise, for an age over 75 when they're not a skydiver, let's call that one medium risk. Okay, now that I've defined this, I can run this test case, and Studio will tell me by highlighting in red where my problems are. Okay, now let's go back to our rule sheet, to our model of the business rules, and identify those problems. So this first rule says if an applicant's a skydiver, they're high risk. This dash means I don't care about age. But if I double-click on this rule, Studio tells me that this is a skydiver, and any of these age categories is high risk. Likewise, age less than 35, a skydiver or not, is low risk. So now that I've shown you that, let me collapse these rules down and show you the features that prove our rule integrity. So this first one, check for conflicts. I click on this, and Studio says, hey, you've got a problem. It highlights it in red. But if I expand these rules out, it says under the precise scenario of a skydiver less than 35, you are giving me mutually exclusive and contradictory actions. So now that it's been pointed out to the business in a way that they can understand it, they can address it. You can say, oh, under this particular case, just like we had stated in our expected results, Rule 1 should override Rule 2. Now, if I check for conflicts, there are none. Very simple resolutions. Next, check for completeness. I click on this, and Studio says, hey, you forgot about the case when somebody's not a skydiver and older than 35. What do you want to do? Well, in this case, we'd already defined that we want to call this a medium risk. So we're going to add in a third rule here. We're going to post an informational message as an audit trail to the applicant record itself, and we'll call this medium risk. Of course, we would write out the full rule statement there. Next, I'm going to do a check for logical loops. Is there circular logic here? No, this is a very simple rule set. There's no circular logic. I'm going to go ahead and save this rule set, go back to my test case, and run the same data through the new rules, and I see my result here. applicant 1 is low risk, no change, but applicant 2 is now high risk, and only the appropriate rule fired. The other one was overridden, and applicant 3 now has a risk, and it matches exactly with my expected results. So this is the gist of Corticon. This very simple way of expressing logic, as I mentioned, scales to handle the most complex decision-making problems. Let me show you that. So this is the same problem, just scaled out a little bit more. So when you have a more complex problem, you can break it into sub-decisions, which is all that this does. So this last rule sheet simply takes the risk from the medical history, the risk of the height, weight, and in reality in the customer, a bunch of other risk determinations to determine a final risk. What I want to show you is this medical history rule sheet. This was represented in about 20 pages of a policy manual from this customer. Okay, people were manually underwriting when we got there and started working with this customer. So after putting this into the product, we found that there were about 20 conditions used across these rules. We used a feature of the Corticon product called compress rules that compressed a lot of these rules to a much more simple representation that's easier to manage. And then we used the integrity features of the product. What we found was, when we first tested this, was lots of conflict across the rules. We pointed this out to the customer, and they said, oh, that's really easy. If they match Rule 1, if they qualify for Preferred Plus, then that overrides everything else. But interestingly, that actually wasn't written down in their policy manual. It's just implicit knowledge that their underwriters have. Now, very interestingly, we came over here and we did a completeness check. And when we click on this button, Studio comes back and says, we've added almost 5 million missing scenarios, which have been compressed down to 11 sets of the population. So that almost 5 million scenarios would take a lot, but by compressing it down to 11 sets, we can actually address this problem in our lifetime. So for example, this rule says if cholesterol level is greater than 280, forgetting everything else, what do they qualify for? When we showed this to them, the customer said, oh, that's really easy. They're not qualified, except for if they're an existing customer, then they qualify at the level that they are. And they simply add another rule, add another condition to define that rule and override the existing rule. So it shows you how this product scales. So I've just shown you literally all of the ways of representing decision-making logic in Corticon. You can layer on top of this a simpler interface in natural language and an interface to be able to manage the rules via the web, via our tooling. Very simple to do that and build this directly into your products. But this is the only way. There is no programming behind this environment. So let's go back to our slides now and talk a little bit more about some of these differentiations. So when you look at how other ways of managing business rules, whether you're using competitive business rules management systems or you're coding your rules, the business specifies the rules, and then the business is limited to changing rules in the templates or business tools that are available to them. A lot of design has to occur from sophisticated developers who need to code the more complex rules, who need to test the combination of rules, and so forth. Now, when you look at Corticon, we're able to reduce a lot of that process down to what we call modeling, which I just demonstrated to you, which can be done entirely by business people that understand the logic but don't understand how to program, or by business people in combination with people that manage the rules in Corticon because they can understand and read the rules in Corticon. So what this does is it dramatically changes the speed at which you can develop applications and the speed at which you can change applications. Actually, this speed is not really linear. It's more exponential, the improvement. So with a simple number of rules, there's not a big difference between Corticon and something else. But when you get to hundreds or thousands of rules, that difference is significant. The NCAAs, for those of you who have been watching basketball, exciting time and customer reference, they use Corticon to determine eligibility for athletics based upon a number of criteria, academic being the most sophisticated. And they built a study determining when they moved from a first-generation rules technology to Corticon exactly how long it took. So guaranteed rules integrity. Very key problem. You've seen how Corticon addresses it. This diagram comes from standard software engineering methodology. We know very well that the longer down the development cycle it takes to identify an error, the more expensive it is to fix, and that grows exponentially. We also know that most errors are introduced in bad requirement specifications. But if the programmers program them precisely, as I did in the very first example, okay, we're not going to find those errors until we go out to user acceptance testing, and hopefully we find them there. If we don't, it maybe would be quite embarrassing if we found them in production. And by the way, we've seen that in a number of customers that have had errors in production for quite some time when they begin to use Corticon. Now, Corticon helps to identify those errors up front when you're actually specifying, capturing the specification of those rules themselves. So next, engine performance. So it's well known in the industry that inference engines that can handle complex decision-making problems, have performance and scalability limitations, specifically with increasing amounts of data. Now, different vendors have provided different algorithms to try to address this, but they all ultimately hit this wall we call the Reedy wall. Now, Corticon identified this very early on and built our own engine algorithm that scales linearly with the amount of data that's being processed. We've actually received a patent on this that's proven to scale very, very well. In fact, this is one of the reasons why Progress acquired Corticon. Progress was using in one of its products the open source engine from Red Hat JBoss. They had built a lot of capability to try to make it easier to manage the rules. Corticon had still gone way, way further on that. But where they really hit the wall, okay, where they just couldn't address it at all, is they went out to customers that had data-intensive problems, and they just couldn't perform and figure out how to make the engine perform. So they ran their own tests, Corticon versus JBoss, and these are the results. Okay, so with that, I want to summarize and say welcome everybody to evaluate Corticon. This is a very easy product, takes just a few minutes to download and install. It's got phenomenal tutorials with it to learn how to use the product. And once you learn how to use it, we welcome the opportunity to work with you and build a prototype that you can then prove to your business. So in summary, lots of business benefits in mitigating risk and optimizing the efficiency of your operations, finding new revenue opportunities, as well as IT benefits in faster development, faster change cycles, and ensuring performance and scalability. So with that, I provide my contact information if you've got questions, and wanted to start taking questions from everybody.
Okay, great. Anyone who has questions for Dr. Allen, please go ahead and submit those through the chat window, and we will be certainly happy to take those. Any questions that we are not able to answer in time, we will answer outside of today's session. So, Mark, I do have one that I am forwarding to you right now.
Okay, great. The question is, how do you deploy the rules in Corticon? So deployment is very simple. Let me explain what's required. So if you're running, you can choose to run Corticon on-premise. You can also choose to run Corticon in a cloud environment. That basically each rule model that I showed you, the rule model itself, is deployed as an individual decision service. So the first thing to deploy is you have to set up your server. So it's a one-time activity, and there are a lot of choices in setting up the server based upon the type of environment that you want to run. Do you want to run this in process within the context of an application? Do you want to run it directly against a database? Do you want to run it in a cloud that many different applications can hit the service, either in a public cloud or a private cloud environment? So there are many considerations there. But Corticon allows you to deploy either as a native Java service, a native .NET service, or as web services that can be called kind of in a lingua franca across applications, or directly against a database using a high-performance batch processor. So lots of different options there. So once your servers are set up, the actual deployment process is very simple. You can publish a rule to a server, literally put that behind a couple of clicks. So, what will be covered in the next 2 webinars on this product? So the answer is we're actually taking some questions. We're going to go quite a bit deeper. We're going to go deeper into some industry examples, and we're going to go deeper into the product capabilities itself. So next one, can we contact Corticon Engine via AJAX from a browser? Yes, absolutely you can. In fact, the example that I told you that had the dynamic forms, that was exactly what it was doing. There are lots of ways to do that. There are some new capabilities to do this, perhaps using Node as well. Node.js is something that one of our customers just started using, a very compelling way to integrate with Corticon. So yes, absolutely. So that you understand, Corticon itself, depending upon the complexity of the rules and the amount of data, can add to the transaction time. Well, in the eBay's case, their average transaction time is less than 10 milliseconds from Corticon. So when you get to very data-intensive processing, it can get to be a lot more than that, but a lot of the simple web-based stuff, less than 10 milliseconds. So you can add that in very fast and have a very dynamic user experience. So next one, how is this integrated with Progress for event triggers? Okay, when something happens in the database, then execute this rule. Also, can the action be an email to a user or execute a report or task program? Okay, so a couple of questions here. So first of all, in the case of an existing Progress client, okay, who is using the OpenEdge product today, Corticon we have invested in a sophisticated integration between those products, making it easy to call Corticon directly from the ABL. So that is specific to Progress OpenEdge. We are working on a similar integration with the Progress role-based product to be able to call Corticon on any event trigger inside of role-based, and that should be coming shortly, the actual release of that. So now, in addition, you can build database triggers and work against any database. So there's lots of options there, but we've specifically invested in the integration with the other Progress products. Now, can the action be an email to a user or execute a report or task program? So the basic Corticon functionality is you send it data and it sends data back, okay? And it sends it back in the format that you send it. And you send it as a Java object payload, a .NET object payload, XML. That's it. You can also connect directly to a database, okay? So in a pure service-oriented architecture, you would not have Corticon interacting directly with anything else, okay? You wouldn't have it go and interacting with another system. You would send back the response and then have the client application actually interact. So that is the recommended architecture. There is a programming model that allows you to extend the actions that Corticon can do through Java, but in a pure service-oriented architecture, we wouldn't recommend doing that. Okay, next one. Pricing. So the question on pricing, there are a variety of different pricing models depending upon what you are trying to do with the product. We sell both to direct end users. We also sell to ISVs and solution providers that want to build it into their platform. The first one, the pricing is based upon the number of CPU cores that you're deploying on the server side. On the latter pricing, it's based upon really a percentage of your overall application revenue, depending upon the amount that Corticon delivers in value to that application. So the next one, we've seen here condition action. Is it possible to place a complex engineering formula? Excellent question. Okay, so as I mentioned, you can extend the Corticon language, okay, through an API. So Corticon comes with a set of functions similar to the Excel function library that covers, let me call it 95% of what our customers do. Okay, 5% they want to go beyond that. Now, I'll give you an example. We have a customer that does investment management for bonds, and they wanted to do accounting using Corticon. And it's a lot of sophisticated mathematical functions. And so they had a library that they had already licensed that they were using in other applications. And they've used our API to integrate that library into Corticon. So it was already an existing function library, and they were able to then use it as part of the rule library, such as weighted average or whatever the function might be. So yes, you can extend our rule language, and it's basically a Java API, and there's also an ability to extend .NET code as well using that API. Let me see the next one. Healthcare customer envisions to handle new policy requests like online auto insurance quotation and purchase the policy online then and there. How can Corticon help? Well, I gave you an example that's very similar to that, to be able to deliver. I think that concept of taking a more manual process and actually converting it into an online process is something that Corticon does very well. And I would also say Corticon in combination with the role-based product is very effective in converting manual processes into automated web-based or mobile-based self-service delivery. Next question. I don't see any difference from what we are doing with the presentation data layer by coding the rules in the database. How it will be integrated with the Java API? I'm sorry, I don't understand that question very well. So maybe you could pose that a little bit differently. Please send me an email on that question, because I think we're at the top of the hour and running out of time. So with that, I want to thank you all very much for your time, and hope we have the opportunity to work with you.